Hello, everybody. Welcome to today's lecture. Today we're going to take a look at Chapter 7. Um, this is a relatively short section. It only has 2 sections in it, but 7.1 is pretty long, so we'll probably only cover maybe about half of 7.1 in this video, and then we'll do the remainder of it in the next video. So this chapter is on... Whoops. Get my color here. It's on what is called... Whoops. Sorry. Voting systems. Okay. So this is something everybody probably has some experience with in some capacity, right? Like maybe you voted in an election, a national election, right? Like the presidential election. Maybe you voted in a local election. Those are the two most obvious examples, but it could also be something more simple, like maybe you voted for homecoming king and queen, or prom king and queen in high school, right? Or maybe you voted for like the class president back in high school or middle school. Maybe you were just voting on like what movie you're going to watch, something like that, right? It's something that it's pretty unavoidable in everyday life, right? Like oftentimes not everybody is going to come to you in a unanimous agreement. So we have to have some kind of voting system to make it fair, right? Now the question is, what voting system should we implement in what circumstance, right? And what even are the voting systems? Probably the most obvious one is, whoever gets the most votes wins. But it's not always that cut and dry. For example, there's not always only two choices, right? If there's two choices, then it might be simple to be like, okay, let's just vote. Whoever gets the most votes wins. There's not really much more you can do there. But what if you have 10 choices? Okay. Now, what if, everybody votes on one and one of them gets 3 choices and 7 of them get 1 choice or 1 vote, sorry. So one of them gets 3 votes and 7 of them get 1 vote and then the rest get 0 votes. Okay. So something like that. Then is it really fair to go with the one that got 3 votes necessarily? Because 70% of people didn't want that one. Only 30% did. So is it really fair to go with that one? Okay, so these are the kind of questions we're going to be looking at. So let's just go ahead and get started. The first definition here is for a voting type called majority rule, which is exactly what I was just saying here. Majority rule is the concept that the candidate or choice. So normally we use the word candidate when it's a person and choice when it's not a person. But they can just be used interchangeably. Receiving more than 50% of the vote is the winner. Okay. So majority rule is the concept that the candidate or choice receiving more than 50% of the vote is the winner. So we have to be a little bit careful here because it has to be more than 50%. It's not necessarily the person who got the most. For example, if there's 3 candidates and candidate 1 gets 40% of the vote, candidate 2 gets 30%, candidate 3 gets 30%. Okay. Well, now nobody has more than 50%. Okay. So we specifically are looking for if somebody has more than 50%, not necessarily just who has the most. So by majority rule, we don't necessarily just pick candidate one because they do not have more than 50%. Okay. So, um, majority rule does not apply here. Okay. And it really shouldn't, right? Because candidate one, only 40% of people want that candidate, but 60% of people don't. So it's not exactly fair necessarily to pick candidate one. Maybe there's a voting system where you do anyway, but you can definitely make an argument for it not being fair. So, what are some alternatives to this? Well, the first one we're going to look at is what we call a preference ballot. So, a preference ballot is a ballot, and I should mention here, a ballot is just something you would, it's just something that you would write your choices on, essentially. Okay. So if you go to vote in like a presidential or local election or something like that, any kind of government election, they would give you a ballot and it would list all the possible choices and you would write down your choices on it. Okay. So that's all a ballot is. A preference ballot in particular is a ballot in which voters choose not only their favorite candidate, but they actually order all of the candidates from their most favorite down to their least. Okay. So it's a ballot in which voters choose not only their favorite candidate, but they actually order all of the candidates from their most favorite down to their least. Okay. So this is one that maybe you don't have any personal experience with, maybe you do, but it's definitely less common than a traditional ballot. A traditional ballot in any kind of government election, like just say like the presidential election, you only get to pick one choice, right? And that's the only one they're considering. This would be if you were to get that and you would be able to rank the candidates in the order that you prefer them. So you would say my first choice is this person, my second choice is this person, my third choice is this person, etc. With all the choices. And then, for example, you would assign like a point value to a first place vote, a point value to a second place vote. Like maybe first place gets 10 points, second place gets 8 points, third place gets 6 points, etc. And then you see how many points everybody gets. The best example I can think of off the top of my head for this is sports. A lot of times, sports will have at the end of the year, they'll have voting for like the MVP, the most valuable player, and a bunch of other things. Like in baseball, there's the Cy Young Award, which is whoever the best pitcher is that year. Um, so there's a lot of different awards they give out. And what will happen is the committee of voters will rank who their first choice is for MVP, who their second choice is for MVP, third choice, etc. And they'll get like 10 choices or something like that. And then they assign point values to all of them, like 10 points for first, 9 points for second, 8 for third, etc. And then they total that up, and whatever player gets the most points, that's who the MVP is. Okay. So let's go ahead and look at an example of this. Okay. Let me pull up an example actually. Okay, so I just found this online. The basketball MVP votes for the 2019-2020 season, the most recent season. So you can see the voters, they go through and they do they get 5 choices, right? So they rank who their first choice is, their second choice, their third choice, their fourth choice, and their fifth choice. Okay. And they can pick from anybody in the league. So they're not necessarily given only a certain amount of choices. So you can see for first place, they give that 10 points. For second place, they give that 7 points. For third place, they give that 8 points. And then fourth place, third points, fifth place, 1 point. Okay. So you can see like the person who won MVP, Giannis, he got 85 first place votes and 16 second place votes. So there's 101 people voting altogether. And that totaled up to 962 points. Whereas LeBron James, he got 16 first place votes and 84 second place votes and 1 third place votes. So almost everybody who didn't pick Giannis for first place picked LeBron. Actually, every single person, because everybody else had 0 first place votes. And most people who picked Giannis for first picked LeBron for second, except one person who picked James Harden. Okay. So this is all, if they were only doing majority rule, if they were only allowed to pick one person, in this case, of course, Giannis would have won, right? But in this kind of system, whoever gets the most first place votes doesn't necessarily win, right? If they were very close, like for example, if it was something like player 1 player 2, okay, then we had first, second, third. Maybe player 1 has 50 first place votes, or even 51. And player 2 has 49 first place votes. So let's just say that there's only 100 voters. But then player 2 doesn't get a ton of second place votes. Okay, so maybe they only get like 19 second place votes, but then they get 30 third place votes. Whereas, sorry, that was player 1. Then for player 2, maybe they do get a lot of second place votes. Whoops. Sorry. Just opened up my settings there. Maybe player 2 does get a lot of second place votes. Like maybe they get trying to make sure these numbers add up here. Second, so 100 minus, maybe they get sorry, I think my numbers are messed up. Let me fix this. Okay, so yeah, so here's a possible scenario, right? Player 2 gets 49 first place votes, and then they get 51 second place votes and no third place votes. Whereas player 1, they got more first place votes, but they got way less second place votes and mostly third place. And let's just look at their totals here. Okay, so the total for player 1 is going to be 51 times 10 plus 19 times 7 plus 30 times 5. Okay. Because that's how many points first, second, and third are worth. So that's 793 points. And then player 2 gets 49 times 10 plus 51 times 7, which is 847 votes. Okay. So with ranked choice like this, or preference ballots, the person with the most first place votes doesn't automatically win. Okay. In this example, they did, and oftentimes they do because it's worth more points. But if they're pretty close, then it's not necessarily the case. Okay. So this is sometimes called, I should mention, as a note, this is sometimes called ranked choice. Okay. I didn't see that word used in the book. I might have missed it, but more colloquially, this is often referred to as ranked choice. Okay. And a lot of people kind of advocate for this kind of voting system in national elections, like the presidential election. But even if not in that, maybe in the primaries. So if you recall what the primaries are, in this country, we have two major political parties, right? We have the Democrats and the Republicans. And which candidate they put forth to become president, and everything else, but normally, we focus on the president. Each party holds what's called the primaries, where they basically give their list of candidates they think would be good, and you can vote on which candidate you think would be the best candidate to go run for president. Okay. So that's called the Republican or Democratic primaries. And many people advocate for a ranked choice kind of primary for that, where you do exactly this, right? So you'd say, I would prefer this candidate, but then next I would prefer this candidate, and then next I would prefer this candidate, and so on. And I mean, there's definitely arguments to be made for that. Okay. Let's go ahead and look at what the book calls a preference schedule. Okay. So a preference schedule is basically this, where you keep track of exactly how many first place votes people got, second place votes people got, etc. The definition here, I'll just write it down real quick, is a table used to organize the results of all the preference ballots in an election. Okay. The only slight difference with the way the book does it is that it's kind of transposed here. The first place goes up and down, and the names go left to right. So let's look at an example of what they have here. They're looking at Um, this is coming from an example in the book. They're looking at the preference ballot for favorite candy. Okay. And they give Crunch. So these are the choices. Crunch, um, miniatures. I'm not sure what that is. Or Snickers. Okay. So Crunch, miniatures, or Snickers. I'm not sure what they mean by miniatures. Maybe just like the miniature candy, but I don't know if they mean one in particular. And they denote these by C, M, and S. Okay. So that's the context for this table I'm going to write down here. So here's the results from the what they call the candy election. Okay, so they asked a bunch of people to choose their favorite candy out of these ones. So they had the number of voters. They have the number of voters going along the top here. So we have 3, 1, 4, 1, 9. And then we have first choice, second choice, and third choice. Okay. And then I'll just fill in the table here that they have, and then I'll explain it. Okay. So they have 3 people who picked miniatures as their first choice, Crunch as their second choice, Snickers as their third choice. 1 person who picked miniatures as their first choice, Snickers as the second, Crunch as the third, all the way down to this one where you have 9 people who pick Snickers as their first choice, miniatures as their second, Crunch as the third. Okay. So, um, how would we go ahead and tally this up? Well, we don't know exactly how many points first, second, and third get because there's different ways we can do it. The way they did it up here is one particular method that we'll talk about in a little bit, but let's talk about some other methods first. Okay. One is called the plural. Sorry, I spelled this wrong. The plurality method. Which is where the candidate with the most first place vote wins. Okay. So the plurality method is where the candidate with the most first place votes wins. So in this case, in the example, okay, who has the most first place votes? Well, we have to total these up. So miniatures has 4, Crunch has 5, Snickers has 9. So Snickers would win. Okay. Now, as I showed with the basketball example, in this example, that is who won, but that's not the method they were going with, right? And I showed here that in a different scenario, the person with the most first place votes wouldn't necessarily have won. So they were not using the plurality method here. I don't think this is super common because if you go through the trouble of ranking all the choices, then there's really no reason that you would just go with the first choice, because then you could have just had everybody pick one and you would have ended up with the same result. All right. You would just had 9 people picking Snickers, 5 picking Crunch, 4 picking miniatures. So when you go through the trouble of doing the preference voting, you're typically not going with the plurality method. Okay. The next method is the one that the basketball example that they do use in real life, and they do that with most sports and with most things that do rank choice in the first place, which is called the Borda count method, or also just known as the point system. Okay. Is where each place on a preference ballot is assigned points the candidate or choice with the highest total points wins. Okay. So just like we saw before with the basketball example, right? So you do have to decide, how many points you're going to give each one, and there's different ways you can do that. It kind of would depend on how many choices you make, right? Like if you're only making 3 choices, maybe you just want to do like 3 points for first place, 2 points for second, 1 point for third place. Or maybe you want to put more weight on the first place one. So you want to give first place 5 points and second place 3 points and third place only 1 point. Okay, which is kind of what the basketball method, or what they did in the basketball method, right? They spaced them out a little bit more. So let's say that so in the next example, they kind of go through this and they say, okay, what if first place got 3 points, second place got 2 points, third place gets 1 point? Then who's going to win this? Okay, so let's go ahead and copy and paste this. Okay, so let's take this and go, 3 points, 2 points, 1 point, and let's see who wins. So the miniatures total points, let's see, they have, from the first column, they have 3 first place votes, so that's 3 times 3. From the second column, they have 1 first place vote, so that's 1 times 3, because you're getting 1 vote for 3 points. From the third column, they have 4 second place votes, so that's 4 times 2 points. From the fifth, from this column, which would be the fourth column, they have 1 third place vote, so that's 1 point. And from the last column, they have 9 second place votes for 2 points. So we just see what that is. We got 9 plus 3 plus 8 plus 1 plus 18. So we got what, 27, 30, 39. Okay. All right, and then we look at we look at crunch. So from the first column, we got 3 second place votes. From the second column, we got 1 first or third place vote. From the third column, we have 4 first place votes. Fourth column, we got 1 first place vote. And from the last column, we got 9 third place votes. Okay. So we got 6 plus 1 plus 12 plus 3 plus 9. 24. So we got 31. Okay. So then finally we got Snickers. So I think Snickers is probably the favorite here because it has a lot of first place votes. But let's see. So we got 3 third place votes, 1 second place vote, 4 third place votes, 1 second place vote, and then 9 first place votes. So we got 3 plus 2 plus 4 plus 2 plus 27. So we got 30, 34, 38. All right. So it got a lot of first place votes. That's where most of its points came from. But it wasn't enough to overtake miniatures. Okay. So miniatures is the winner here. Okay. Hershey's miniatures, actually, the book says. I must have missed that. Oh yeah, they did not mention that. Okay, so this is so this is one voting method called the point system. Like I said, this is usually what's called the ranked choice. If you're using the plurality method, that's not usually ranked choice because then you're not actually ranking the choices. You're just giving I mean, you are ranking them, but you're not giving point values to them. Usually when you say ranked choice, it implies that there's point values also. Okay. So now let's look at some more methods here. Okay, before we look at the other methods, let's look at this theorem here on page 238. So, we often are asking ourselves, we have all these different methods of voting. Which one is the most fair, right? We only have a couple methods right now, and there's 2 more in the book that we will come back to after this theorem. Let's think about here what this says. Arrow's, this is called Arrow's impossibility theorem. So this says that no voting system can satisfy all 4 fairness criteria in all cases. Okay. And we're going to list what those 4 are. So far we've looked at majority voting and uh, plurality method with the preferences and the point system with the preferences. Okay. Um, but this says no voting system can satisfy all four fairness criteria in all cases. Okay. So it's a little demoralizing, right? Because this is saying basically that there's no perfect voting system. No matter which one you pick, it's going to have problems. And that's true, right? I mean, we see that um, with any of our elections, right? We use in the presidential election what is called the electoral college system. And there's a lot of criticisms of the system, right? It works well in some instances, and there's definitely arguments for it, but there's a lot of arguments against it. Okay, so it's definitely not a perfect voting system. For example, back in the 2016 election and in a lot of elections, the person who gets the most votes in the country doesn't end up being the president, right? In 2016, Hillary Clinton got about 3 million more votes than Donald Trump overall in the country, but still lost the election because of the electoral college system, right? So that's a major criticism of the system. The arguments for the system is that it kind of puts more of the power into the individual states themselves, right? Because we're supposed to be the United States, so we like to think of our country as like 50 individual states. So it kind of gives more power to the states. In theory, it doesn't always work that way in practice. So we can see just from our country's voting system, we can see why this might be true, right? We might think, okay, there's obviously problems with our voting system. Why do we go with it? And what this says is that, well, there's problems with every voting system, right? So maybe we should change it. But the idea that this says is that even if we did change it, there would still be problems with that system as well. So let's take a look at what these 4 fairness criteria are, though. Okay. So the fairness criteria. So number 1 is the majority criterion. So this says if a candidate receives a majority of first place votes in an election, then that candidate should be the winner of the election. Okay. So this is called the majority criterion. And it states that any candidate who gets the majority of the first place votes in an election should end up being the winner. We've already seen this violated a couple of times, right? If we go back up, if we go to this example, right, Snickers got the most first place votes but did not end up the winner. In the example I made up, with the basketball example here, in the one I made up, the person who got the most first place votes wasn't the winner. We did see in this voting method, it's possible, and in fact probable, that the person with the most first place votes does win. It's just not guaranteed. Like I said, in our presidential elections, like in 2016, the person who got the most votes did not win the election, and it happens all the time. Back in 2000, with George Bush and Al Gore, Al Gore got more votes overall, but George Bush was still the president. So we see this criterion violated constantly, basically. But it is the first of the four fairness criterion. And whether you think it really should be the case, like that this really should be this important, it's kind of a matter of debate, right? And obviously in America, we've kind of decided it's not that important because that's not how our elections work, right? A lot of people do think it is, but overall, that's not how the system was put into place. Number 2 is called the Condorcet criterion. I might be saying that wrong. I'm not sure. But I'll just say Condorcet criterion. If there is a candidate that in a head to head comparison is preferred by the voters over every other candidate, then that candidate should be the winner of the election. Okay. And that candidate is called the Condorcet candidate. So if there's a candidate that in a head-to-head comparison is preferred by the voters over every other candidate, then that candidate should be the winner. So if we just think about like the Snickers versus the Hershey miniatures versus the Crunch bars, right? We would have to look and say, okay, what if we did miniatures versus Crunch? Who wins? And then we do miniatures versus Snickers. Who wins? So you kind of do it like a tournament bracket, almost, right? And then the last one you do Crunch versus Snickers. Who wins? And you would take the winners and then put them head to head, see who wins, and then that should be the winner. So this is kind of going along with the method of pairwise comparisons, which we haven't talked about yet, but we'll get to that one. So let's just think of an example here. Okay, if we go up to our basketball example, we can see clearly Giannis is favored in comparison to LeBron, right? Because he got 85 of the first place votes versus LeBron 16. And then if you went and said, okay, what about Giannis versus Harden? Well, he clearly wins, right? 85-0 votes. And then you go Giannis versus Luka. He still wins, right? Because it's 85-0 and so on. You just do that with everybody. So if you have Giannis go up against every individual person, he would come out ahead, right? He would be the winner in all of those. So what this fairness criteria is saying is that he should win. Okay. So far with this voting method, both of the first two fairness criteria are being adhered to. All right, let's look at the third one called the monotonicity criterion. Okay, monotonicity means that it keeps going in one direction and it doesn't change. Okay. So this says if candidate, so they call it candidate X, meaning it could just be whoever, right? Is a winner of an election and in a re-election the only changes in the ballots are changes that favor X then X should remain a winner of the election. Okay. So X wins an election, and then when it comes time for re-election, the ballots are pretty much the same, and any changes that are made are things that favor that candidate. Then it says that they should win. So basically, if you go to the next election and nothing has changed, then they should still win. Okay. So in other words, they didn't just win by random chance, because when you did it again, they still won, right? Obviously, in something like the presidential election, um, it's really hard to judge something like this because it's very unlikely over 4 years absolutely nothing would change, right? Lots of things change, like presidents make um, decisions and they make policies and they sign things and whatever, they take things away and it changes people's opinions of them over that time. And of course, they're going up against a different candidate in the next election. So we'll look at some examples that violate this later. So hope it'll be a little easier to understand then. Okay. But the gist of it is that if nothing changes by the next election, they should still win. Okay. The last one is, it's a long name here, the independence of irrelevant alternatives. Criterion. The independence of irrelevant alternatives criterion. Okay. So if candidate X is a winner of an election and one or more of the candidates is removed and the ballots recounted, then X should still be a winner of an election. Okay. If candidate X is a winner of an election and one or more of the candidates is removed and the ballots recounted, then X should still be a winner of an election. So, we can see an example of this again in the presidential election. You know, we typically have the two major political parties, right? We got the Republicans and we got the Democrats. Let's say the percent of their vote. So, but these aren't the only two. These are just the primary two, right? These are the biggest two. So, you know, let's say in an election, the Republicans get 45% and the Democrats get 48%. Okay. So this isn't adding up to 100, right? There's still 7% unaccounted for. So then there's a couple of smaller parties that do typically get some of the vote. There's the Libertarian Party and there's the Green Party. Okay, the Libertarian, they're usually a little bit stronger. So let's say they get 4%. The Green Party gets 2%. And then we got other over here for 1%. Okay. Now here's the catch. Almost always the Libertarians, if they don't go with the Libertarian candidate, they typically go with the Republican candidate. Not always, but usually. Whereas the Green Party typically out of the two pick the Democratic Party more often. So what if we just took the Libertarian Party out and we gave all their votes to the Republicans? Okay, so maybe whoever was voting for the Libertarian, they're gone, so now they decide, okay, I'm just going to vote for the Republican. Then now they have 49%, right? And now they win the election. So, you know, assuming whoever gets the most votes win the election, which isn't the case in our country. But, so we can see how this fourth one would be violated. If you take out one of the alternatives, so the so-called irrelevant alternatives, they're irrelevant in the sense that they're not even close to the vote percentages of the other two. But when you take them out, all of a sudden the election is completely different. Okay. So that fairness criterion here would be violated in this case. So if the Libertarian or Green Party took enough of the vote to, you know, siphon off some of the votes from one of these parties, and it's enough that it changes the outcome of the election, then that fairness criterion is violated. Okay, so these are the four. We got the majority, the Condorcet, the monotonicity, and the independence of irrelevant alternatives. Okay. We've seen examples of how most of these can be violated with the exception of the monotonicity. So next time we're going to look at an example of that one. We'll look at the last two voting methods, and then if we have time, we'll get started on 7.2. So thank you guys for watching today, and I will see you then.